Welcome to SciSpectrum Lab Essentials, your source for equipment, instrument, and consumables.
Have you ever wondered how you measure something you can't even see? Well, today we're going to break down the Flame Photometer, an incredible piece of tech that literally uses fire to reveal the hidden elements all around us.
So let's start with a little bit of a mystery. Imagine you've got a blood sample, right? Or maybe a bit of soil mixed in water. How in the world do you figure out exactly what's dissolved inside? We're talking about individual elements just kind of floating around in there, totally invisible.
And this isn't just some academic puzzle. It's a really critical question in fields like medicine and agriculture. Knowing the precise concentration of certain elements, it's absolutely vital for everything from diagnosing a patient to making sure a harvest is healthy. We're talking about really specific, crucial elements here, like sodium and potassium. For a doctor, a patient's exact sodium level is a big deal. Even a tiny imbalance can mess with nerve function and blood pressure. And for a farmer, well, having the right potassium level in the soil can be the difference between a great crop and a total failure. But again, how do you count them when they're just ions in a solution?
Well, the solution is actually surprisingly beautiful. What we do is give these invisible elements a chance to glow. We basically make them sing their own unique song, but with light instead of sound.
And that's where a technique called flame photometry comes in. It's built on this simple but brilliant idea. When you introduce certain elements to a flame, they get energized and they emit light of a very specific characteristic color. And this right here is the perfect example. It's like elemental fireworks. Sodium burns with this intense, unmistakable yellow. Potassium gives off this beautiful lilac or pale violet color. Every single element has its own unique color signature. It's like a fingerprint made of light.
Okay, so let's actually follow a single drop of a sample as it goes on its journey through a modern flame photometer. We're going to see exactly how this machine turns a simple liquid into a precise measurement.
The whole thing happened in 5 key stages, all automatically, right inside the machine. It goes from sucking up the sample all the way to detecting the light it produces. So let's break down each step. The journey kicks off with something called aspiration and atomization. Basically, the machine sucks up the liquid sample and then shatters it into a superfine mist, almost like an aerosol spray. This is a really important step to get the sample ready to go into the flame evenly.
Next, that fine mist gets mixed with fuel, in this case LPG, which is just liquefied petroleum gas, and air inside a special chamber. Then, that mixture is sprayed right into the burner. And the moment that mist hits the flame, boom! Those specific elements inside get all energized, and they start glowing with their signature colors.
Now here's the really clever part. The light from that flame, which has lots of different colors in it, passes through a very special filter. So if we're looking for sodium, this filter is designed to block out everything except for that intense yellow light. It isolates the exact color we're looking for. And the final step is detection. That single pure-colored light hits a photodetector. And this detector has one job: measure how bright that light is. And here's the key takeaway. The brighter the light, the higher the concentration of that element in our original sample. Simple as that. Okay, so we've got a brightness level, great. But how does the machine turn that into the exact data, the parts per million that a scientist or a doctor actually needs? This is where the brain of the operation takes over. The signal from that photodetector goes to an advanced microcontroller. This is the bit that does the translation, turning that raw light intensity into a meaningful, precise number.
So how does the machine get so accurate? Well, a key feature is something called multi-point calibration. Before running a real test, the lab tech runs a few samples that have known concentrations. This lets the machine's software create this super precise reference curve, which makes sure the final results are incredibly reliable.
And all this smart processing means the instrument is incredibly versatile. It can measure totally different concentration ranges depending on the job. Like it can analyze the really low levels of potassium you'd find in blood serum, but also the much higher levels you'd find in a urine sample. And that milliequivalents per liter you see? That just stands for milliequivalents per liter. It's a standard way to measure electrolytes in medicine.
But it's not just about that core process. Modern flame photometers have all these intelligent features built in that just make them safer, faster, and way more reliable for the people using them in the lab every day.
And of course, when you're working with a flame and combustible gas, safety is a huge deal. These instruments are designed with that in mind. If the flame accidentally goes out for whatever reason, the device spots it instantly and automatically cuts the gas supply. And that little computer brain we talked about, it also powers a bunch of modern conveniences that make a lab tech's life way easier. It can store test results, save entire testing setups to use later, and you can even hook up a printer to get reports directly.
So, at the end of the day, what's this all for? All of this sophisticated tech really comes together to serve two vital fields. In medicine, it's helping doctors make critical diagnoses by analyzing blood and urine. And in agriculture, it's helping scientists analyze soil so we can all grow healthier food.
And get this, one of the coolest things is just how efficient it is. The system can be set up to measure sodium, potassium, calcium, and lithium, all from the exact same single draw of the sample. That's 4 results from one test, which is a massive time saver in a busy lab. Ultimately, the flame photometer just shows us how a simple, elegant principle, the idea that elements have unique color signatures, can be engineered into this powerful tool for revealing the unseen world. It really makes you wonder, what other secrets are hiding in plain sight in the liquids all around us?